All right, this is going to be page 43 of math analysis, and we're going to graph two functions and then be on our way. So hopefully this will be a shorter video. Last time went a little long. I didn't realize. Basically, it's like if I change my train of thought halfway through, I went from graphing to solving and talking about that. It's like I reset the timer in my brain. So apologize about how long that was. And also, I'm probably making this longer than it needs to be by talking about it. So let's get down to this. So sine -3 sine 2 pi over 5x plus 4 pi over 3, and then minus 1. Period. 2 pi divided by b, which is 2 pi over 5. So what does that give us? That gives us, I think, just 5. So then our increment's going to be weird because it's the period divided by 4. Well, it's not weird, but it's 5/4. It's not great, basically, is what I'm saying. Starting point. All right, so to find the start, what I do is I take whatever is in parentheses, set it equal to 0 and solve. I don't have a lot of space for that, so I'm going to do it up here. So 2 pi over 5x plus 4 pi over 3 equals 0. And then I'm going to solve. So, and that's all I do every time. So here I'm going to get 2 pi over 5x is equal to negative 4 pi over 3. So I'm going to multiply by 5 and divide by 4. So negative by 2. Multiply by 5, divide by 2 pi. Technically, the pi's are just going to cancel out. So we get negative 20 over 6. So I get x is negative 10/3. Okay. So where's that going to impact us? Well, it's not going to really impact us, but I am going to give you the number one tip that I can give you when you're working on these, and that is get a common denominator between your increment and your starting point. If you don't do that, every calculation is a ton harder. But this, I'm going to get a common denominator of 12, I think. So it's going to be 15 over 12. This is going to be negative 40 over 12. What that's going to allow me to do is I can just constantly add the increment without worrying, right? Because they already have a common denominator. So that's kind of a pro tip for these. So y equals -1. So our maximum and our minimum, they don't depend on the sine of a because you're just at the sinusoidal axis, you go up a, the absolute value of a. So I guess it does. But you go up the absolute value of a, that's a maximum. You go down the absolute value of a, that's a minimum. So this will be -1 plus 3, which is 2. And this will be -1 minus 3, which is -4. So we got to go from 2 to -4. So let's see. I'm going to do, I think this is the same range as last time. So if I put 2 here, I think that's going to work. 0, -2, -4. You get 3 boxes at the bottom, 2 at the top. It doesn't really make a difference. So I'm going to put in my x-axis and then maybe move it if it doesn't show up in the right place. Okay, so let's just to make it look better, let's move this up a little tiny bit. All right, and then what I'm gonna do is I'm gonna take the starting point, right? So the start is -40 over 12. I'm gonna take the starting point and put it in the center, or as close as I can get to the center. So I think I'm gonna, whoa, I'm gonna make this -40 over 12 because that's my start, right? Once I have my start, what I'm going to do is I'm going to add the increment. So 2 boxes, and then it's 15. So that's -25 over 12. So all I have to keep doing is adding 15 to the numerator because we already have a common denominator. That's why you want to do that. So -10, and then +5, and then 20. Okay, so do we have this right? Well, I did 4 increments, right? So 4 increments, it's 1 increment, 2 increments, 3 increments, 4 increments. 4 increments should be 1 period. So if I check and do the distance between them, 20 minus -40 is 60 over 12, which is 5. 5 is the period. That means we did that right. Or we made weird offsetting mistakes somewhere in the middle, which I don't think I did. And then this way, it's going to be -55 over 12, -70 over 12, -85 over 12. So what is that? 1, 2, 3 increments. -100 over 12. And you can see the distance between those is definitely 60 over 12, which is 5. And then I can fit one more. I don't think I centered this as well as I did the last time, but you know, that's all right. It doesn't actually impact your graph. So the next step, sinusoidal axis. Sinusoidal axis in this case is going to go right through all those numbers that I just drew. So that's annoying, but nothing I can do about it. So it's y equals -1. So I'm going to do the same thing that I did last time where I like make a line and then use it kind of as a guide for this. So here, and when you're doing it by hand, obviously you just kind of like go for it. But if you have the aid of technology, you know, maybe you use it. Maybe you don't. It's up to you. I don't know. Here. Okay, and then I'm gonna erase that line. It's like I'm doing a tutorial on like the drawing of graphs, not just how to graph, the actual drawing of graphs. All right, so at the starting point, so the starting point in our case is -40 over 12. This is our starting point. We're going to be, so what's our pattern? Well, it's negative sign. So negative sign is intercept, minimum intercept, maximum intercept. Remember, the original sine graph, think of the unit circle. You start at 0, you're at the point 1, 0, so y is in the middle. And counterclockwise, y increases, which means when you do negative sign, you're going to start in the middle and decrease. So we're going to start in the middle, so that's on the sinusoidal axis. And then we go over an increment, we go down to a minimum, over, and we go intercept, over and up, over and intercept. And then I can actually fit it because it's 2 boxes away, so I'm going to do it. And then this way we'll go here, here. It's like you're going to know if you screw up because when you go to graph, it's just going to look very wrong. And then I can actually fit this too. Why can I fit all of those this time? Could I have done that last time? I didn't feel like I could do that last time. I don't know. Maybe I messed something up. But or maybe by not centering it correctly, I gave myself more like a weirdly more accurate graph. I don't know. All right, so let's sketch this. I think it's best to do a quarter of the graph at a time. But I mean, if you have a steady hand, I do not have a steady hand. If you have a steady hand, you could probably do this in one shot. Also, I'm of the opinion that this is easier to do on paper. I don't know if that's true or not. Also, if I was doing it on paper, I'd probably be like, this is easier to do on the computer. So, you know, whatever. Take that advice for whatever it's worth. Could just be excuses. All right, I believe this is our graph. So, intercepts that I see. The intercepts that I see are, I'm only going to write the ones that I really need, right? So, I see negative, you know, the problem is I've put like lines through everything, but definitely -40 over 12 is one of them. And then -10 over 12. And then I'm going to say that 20 over 12. Now you might notice every time I was just adding 30 in the numerator, which makes sense with we have the common denominator, and 30 over, what am I doing? 30 over 12. Why does that make any sense? Does it make sense if I subtract 30, subtract 30? Yeah, that's 30 over 12. Oh God, 30 over 12 is, what is 30 over, let me do this. 30 over 12. I'm going to divide through by 2, 15 over 6. I'm going to divide by 3 and get 5 over 2. 5 over 2, half the period. That's exactly what it should have been because intercepts happen half of the period apart. So yeah, obviously. So I'm going to use the positive one because I'm kind of partial to that. But you're free to use any of them as kind of like the anchor. And then n is an element of the integers. So that's a pretty good graph. I'm actually going to stop the video here because, you know, they're taking a while because I'm trying to explain everything, every part. And I don't want you, you know, to watch this for hours. I will point out that we could solve 3 really nice equations here. So the first one we could solve, well, this isn't, I mean, I don't know what the first one means, but you could solve f of x equals 2. You can solve f of x equals -1, which is the sinusoidal axis. Those are the intercepts. We actually did solve that one. Or you could solve f of x equals -4. You get 3 nice equations for every trade graph. So be on the lookout for those. I'm going to stop this here, come back, finish this page. I'll see you in the next video.